NFPA 20 and 70 allow for shared service. NFPA 20-9.3 2.2 states that the service conductor shall be independent of all other electrical services in the building, but service conductors shall be permitted to be shared by more than one fire pump when permitted by the authority having jurisdiction. NFPA 7-695.3a states that the normal electrical service shall be independent of and separate from the emergency electrical service source. The normal electrical service shall be permitted to serve the emergency electrical system during non-emergency conditions. The National Fire Protection Association, or NFPA, has clarified that it allows shared service for fire pump controllers, provided it is properly designed and installed. Factory Mutual, or FM, Publication 9101, Approval Standard for Automatic Fire Pumps and Water Supply Systems, allows shared service for fire pump controllers and load feeders, provided they can handle the combined load. Underwriters Laboratories, or ALL, Standard 1003, Standard for Firefighting Equipment Service, allows shared service for fire pump controllers, provided it meets certain performance criteria. Here are arguments to support shared service. Firstly, utilities have contingency plans in place to ensure power restoration in the event of an emergency. They can coordinate with fire departments to access critical circuits if necessary. Secondly, the NFPA and other codes explicitly allow for shared service for fire pump controllers, provided the design and installation meet specific requirements. Thirdly, dedicated primary feeders and transformers are expensive investments that may not be necessary in all cases. Fourthly, a shared service can provide a more reliable power supply in the event of a fault on the primary feeder. Fifthly, in some cases, having multiple services entering the building can provide added redundancy in the event of a service outage. Based on the above information, it appears that an insurance underwriter's interpretation of NFPA 20 and 70 may be overly conservative. The codes allow for shared service for fire pump controllers, provided it is properly designed and installed. The codes and standards should be presented to advocate for a more reasonable solution that complies with the applicable codes and standards. It's important to delve deeper into the specific requirements outlined in NFPA 20 and NFPA 70, focusing particularly on Article 695 within NFPA 70, which addresses fire pumps. Within Article 695, understand the requirements for the source of power, which includes reliability and capacity. The code specifies that the power source must be reliable and capable of carrying the fire pump's lot rotor current, and voltage drop considerations are crucial here. When discussing the independence of the normal electrical service, emphasize that while it needs to be separate from the emergency source, it can indeed serve other loads under normal, non-emergency conditions. The key here is preventing any fault or outage on the normal service from impacting the fire pump's operation during an emergency. Go through the protection requirements meticulously. These requirements cover overcurrent protection, short-circuit protection, and ground fault protection. The goal is to ensure that the fire pump circuit is adequately protected without causing nuisance tripping that could disable the pump during a fire. The NEC allows the use of devices like circuit breakers and fuses, but with specific coordination requirements to ensure selective tripping. Voltage drop is a critical factor in fire pump installations. Excessive voltage drop can significantly reduce the pump's performance, affecting its ability to deliver the required water pressure. The NEC sets limits on voltage drop to ensure the pump operates within its design parameters even under full load. When arguing for shared service, highlight the design considerations that ensure reliability. For example, implementing automatic transfer switches, or ATSs, can switch the fire pump to an alternate power source if the normal service fails. Ensure these ATS are properly sized and maintained to guarantee their effectiveness. Coordination with the local utility is paramount. Discuss the utility's ability to provide a stable and reliable power supply. Utilities often have redundancy measures and backup systems to minimize outages. They can also coordinate with fire departments to prioritize power restoration to critical facilities like buildings with fire pumps. Review any existing contingency plans or agreements that outline these procedures. Conduct a thorough load calculation to demonstrate that the existing service can handle the fire pump's load in addition to the building's normal loads. This calculation should take into account the pump's starting current, running current, and any other connected loads. It's important to show that the service has sufficient capacity to meet all demands without overloading. Presenting cost-benefit analyses can strengthen the argument for shared service. Compare the cost of installing a dedicated primary feeder and transformer to the cost of upgrading the existing service to accommodate the fire pump. Demonstrate that the shared service option is not only code compliant but also more economically viable without compromising safety or reliability. Redundancy is another compelling argument. Explore the possibility of incorporating multiple power sources or backup generators to enhance the system's reliability. Explain how these redundant systems can provide an additional layer of protection in case of a primary service failure. By showing that the shared service design includes adequate redundancy, one can alleviate concerns about single points of failure. Address the insurance underwriter's specific concerns directly. If their concern is that the utility might disconnect power to the building during a fire, provide documentation or assurances that the fire pump circuit will be isolated and protected from such actions. Explain the coordination protocols between the utility and the fire department to prevent inadvertent disconnections. Highlight the fact that shared service is a common and accepted practice in many jurisdictions. Provide examples of successful installations where shared service has been used for fire pumps without any adverse effects. This can help demonstrate that the approach is reliable and safe when implemented correctly. Refer to industry best practices and guidelines related to fire pump installations. Organizations like the Fire Protection Research Foundation, or FBRF, and the National Electrical Manufacturers Association, or NEMA, publish valuable resources on fire pump system design, installation, and maintenance. Citing these resources can add credibility to the argument. Explain the specific measures that will be taken to ensure the fire pump's reliability and performance. This may include regular testing and maintenance of the pump, its controller, and the electrical service. Show that there's a comprehensive plan in place to maintain the system's readiness in case of a fire. Address any potential risks associated with shared service and explain how those risks will be mitigated. For example, if there's a concern about voltage fluctuations, describe the steps that will be taken to stabilize the voltage and prevent it from affecting the pump's operation. The authority having jurisdiction, or OJ, plays a crucial role in approving fire pump installations. Consult with the AHJ to ensure that the proposed design meets all applicable codes and regulations. Obtaining their approval can provide additional assurance to the insurance underwriter that the installation is safe and compliant. Provide detailed documentation of the electrical design, including schematics, wiring diagrams, and calculations. This documentation should clearly show how the fire pump circuit is connected to the shared service, how it's protected, and how it complies with all relevant codes and standards. Invite the insurance underwriter to visit similar installations where shared service is used for fire pumps. This can give them a first-hand look at how the system operates and how it's maintained. Seeing a successful installation can help alleviate their concerns and build confidence in the design. Ensure that the fire pump controller is listed and labeled in accordance with UL 218, the standard for fire pump controllers. This listing demonstrates that the controller has been tested and certified to meet specific performance and safety requirements. Address the coordination between the fire alarm system and the fire pump controller. The alarm system should be able to automatically start the fire pump in the event of a fire. Ensure that the interfaces between these systems are properly designed and tested. Explain how the fire pump system will be inspected and tested on a regular basis to verify its performance. This may include annual flow tests, electrical tests, and mechanical inspections. Show that there's a robust testing and maintenance program in place. Address the specific requirements for the fire pump room, including ventilation, lighting, and access. The room should be designed to protect the pump and its controller from environmental hazards and to provide adequate space for maintenance and inspection. Provide a written statement from a qualified electrical engineer certifying that the shared service design meets all applicable codes and standards. This statement can provide additional assurance to the insurance underwriter that the installation is safe and compliant. Discuss the potential for future expansion or upgrades of the electrical service. Ensure that the shared service design allows for additional capacity to accommodate future needs without compromising the fire pump's reliability. Explain how the shared service design minimizes the risk of electrical faults or disturbances that could affect the fire pump. This may include the use of surge protection devices, harmonic filters, and other mitigation measures. Address the potential impact of power quality issues on the fire pump's performance. Poor power quality can cause the pump to operate inefficiently or even fail prematurely. Describe the steps that will be taken to ensure that the power supply to the pump is clean and stable. Discuss the potential for using renewable energy sources such as solar power or wind power to supplement the electrical service for the fire pump. Explain how these renewable sources can enhance the system's sustainability and reduce its reliance on the grid. Address the specific requirements for grounding and bonding of the fire pump system. Proper grounding and bonding are essential to prevent electrical shock hazards and to ensure the proper operation of protective devices. Provide a detailed explanation of the grounding and bonding methods that will be used. Discuss the potential for using energy-efficient fire pump motors and controls. These technologies can reduce the energy consumption of the fire pump system and lower its operating costs. Explain how the shared service design takes into account the potential for future changes in codes and standards. Ensure that the design is flexible enough to accommodate future requirements without major modifications. Address the potential for using smart grid technologies to enhance the reliability and efficiency of the fire pump system. Smart grid technologies can provide real-time monitoring and control of the electrical service, allowing for proactive management of power quality and system performance. Discuss the potential for using battery backup systems to provide a temporary power supply for the fire pump in the event of a grid outage. Battery backup systems can ensure that the pump continues to operate even when the primary power source is unavailable. Provide a detailed explanation of the fire pump controller's features and function. The controller should be able to automatically start and stop the pump, monitor its performance, and provide alarms in the event of a problem. Discuss the potential for using remote monitoring and control systems to manage the fire pump system. Remote monitoring systems can provide real-time visibility into the system's status and performance, allowing for proactive maintenance and troubleshooting. Address the potential for using predictive maintenance techniques to identify and address potential problems with the fire pump system before they cause a failure. Predictive maintenance techniques can help to extend the lifespan of the system and reduce its downtime. Discuss the potential for using data analytics to optimize the performance of the fire pump system. Data analytics can provide insights into the system's operation, allowing for improvements in efficiency and reliability. Address the potential for using cybersecurity measures to protect the fire pump system from cyber threats. Cybersecurity measures are essential to prevent unauthorized access to the system and to ensure its continued operation in the event of a cyber attack. Provide a detailed explanation of the emergency procedures for the fire pump system. These procedures should cover topics such as power outages, pump failures, and fire emergencies. Discuss the potential for using virtual reality, or VR, and augmented reality, or AR, technologies to train personnel on the operation and maintenance of the fire pump system. VR and AR technologies can provide immersive and interactive training experiences that enhance learning and retention. Address the potential for using artificial intelligence, or AI, to optimize the performance of the fire pump system. AI can be used to analyze data from the system and to make recommendations for improvements in efficiency and reliability. Provide a detailed explanation of the life cycle costs of the fire pump system. This should include the initial cost of the system, as well as the ongoing costs of operation, maintenance, and repair. Discuss the potential for using sustainable design principles to minimize the environmental impact of the fire pump system. Sustainable design principles can help to reduce the energy consumption, water usage, and waste generation of the system. Address the potential for using prefabricated components to speed up the installation of the fire pump system. Prefabricated components can reduce the time and cost of installation, while also improving the quality and consistency of the system. Provide a detailed explanation of the warranty coverage for the fire pump system. The warranty should cover defects in materials and workmanship, as well as the cost of repairs and replacements. Discuss the potential for using performance-based contracts to ensure the long-term reliability and efficiency of the fire pump system. Performance-based contracts can incentivize contractors to maintain the system in optimal condition and to meet specific performance targets.